So, hello everyone, my name is Eduardo Silva. I work for this company called Treasure Data, that now we are ARM Treasure Data. So it's a company that was acquired a few months ago. Everybody's happy, no worries. The projects continue working on it, so we have more resources to hire more people. So we are hiring, so if you're interested, just come to us to talk. So at this company, I work as a principal engineer at ARM. And I maintain this project, which is called Fluent Bed, which is the Fluent D project ecosystem. I'm sure that most of you are familiar with Fluent D. Oh, please raise your hands if you're familiar with Fluent D. OK, perfect. We're good. So Fluent Bed is like a sub-project of Fluent D. It not tries to compete. It's the same family, but we try to solve all the gaps that we have in Fluent D. And also, both projects continue growing at their own phase with their own maintainers, but same team, and trying to increase the communities. So let me turn off this. There's no backup now. So in terms of logging, everybody knows that we do logging not because it's fun. We do logging because we need it, because we want to achieve some data analysis, right? I will say that logging is kind of boring. Yeah, it's not something that you want to be looking every day. You just take a look when you want to see some metrics, or why something is failing, or why your things are not right, right? But our focus is always data analysis. So, and the challenge with data analysis comes from that the data come from multiple sources of information. This comes from TCP, UDP, log files. We talk about log files, but anyways, they are a stream of data. And also, this data comes in different formats: unstructured messages, JSON, LTSV, or any kind of new developer invented their own format. And so we get a lot of problems. But at the end, the challenge is how do you correlate all this data come from different places for different formats in one central place, because we want to do data analysis. So years ago, when Fluent D was designed at the company, the team behind it said, OK, if you're going to deal with data that come from one place to another, there are many phases in the middle and many things that we need to solve step by step. And anyways, if we want to implement logging or solve any problem in our logging layer, we need to understand how it works internally. Without this knowledge, it's really hard, because it's easy to say, oh, this is not working. But sometimes it can be your input source of data or any kind of phase in the middle. So we come up with this design, which is called the logging pipeline, where you say that at the beginning, you have some, oh, this got stuck. Give me 1 second. There you go. So when you collect the data from some kind of input source of data, right? But this data then needs to be parsed. Maybe it doesn't have a structure. You need to give a structure to this data, or maybe this data have a structure, but you need to tell the log processor how to operate this data. Because don't forget that our goal is data analysis. So we're in the phase before that. And after we parse the data, sometimes you're not interested in the whole data that you are getting in. Maybe you want to filter data out, or maybe you want to add some kind of metadata or enrich your logs with additional information. Common cases are like, I want to add my host name to the logs, or my IP address, or hardware address, or anything like that. Once you collect the data, parse the data, and filter the data, this data is going to be stored in a temporal place for a fraction of seconds, or maybe a couple of minutes. And for that, you need something that is called buffering. Well, any program running a computer is running in memory. So buffering is not something new. But for reliability, sometimes you need to provide different mechanisms for buffering. So because what happens, maybe you are going to route the data to a different destination, because maybe your end is to store in Elasticsearch, maybe it's Kafka, NATS, or whatever. But maybe what would happen if one of the output is not working, or maybe you got a network outage. So here is where your buffering is really important, because if something is wrong, you have your backup of data that you can retry later, so you don't lose data. But if you don't have a good buffering mechanism, you have the risk to lose data if something happens. OK? So now talking about Fluent Bed. Fluent Bed is a project that born on 2015. And I'm going to tell you the truth. It born for embedded Linux. That was the original idea for Fluent Bed. because we have Fluent D and people from the embedded side or the IoT space with some small boards, they say we need a log processor, we need to collect the data, we need to parse this, but sometimes Fluent D can be a little bit heavy. So we come up with starting writing this project from zero, and after 1.5 years of the project, we got something functional, we got some plugins in place, and people said, you know, the embedded market is quite fragmented. Everybody writes their own solution. It's not like in the cloud, where everybody tries to see, oh, you're writing this component, maybe I can use it, let's try to merge this in a new project. It's totally different. But people from the cloud space pay attention to Fluent Bed, and they say, hey, I need something lightweight to process my logs in Kubernetes. I'm using Fluent D, I'm pretty happy, it has aggregation and everything, but I need something that consumes less memory and less CPU because I have 100 of nodes. And that is a valid statement. So Fluent Bit is written originally and still in C language, and that will not change, I hope. It's tried to have a low memory and low CPU footprint. If you start Fluent Bed and you do nothing with it, it will consume around 500 kilobytes. But of course, if you ingest data on it, you know, your buffers, your memory will go up. So when everybody says, oh, my tool is using this amount of memory, I'll say that's a minimum. But if you're doing some working a lot with a lot of load of records, that will change. And we have a pluggable architecture. So when I talk about Fluent Bed, I always say that Fluent Bed is not something designed from scratch, because we took about, okay, what's wrong with Fluent D, what are the best practices of Fluent D, and what we can do better. So we took the same design of a logging pipeline and say one of the big things and good things about Fluent D that it has a huge ecosystem. I'm not sure if you know, but we have like 800 plugins. And our company maybe maintain 20, no more than that. So all of the 780 plugins are made by different individuals and companies. And all of that is possible because the whole logging pipeline and the different phases that I just described, like input, filter, parser, and so on, are plugins. So in any case, if you have any kind of a problem in your environment, what you do is to just write a plugin for something that is missing to solve your own problem. So we implemented also plugins in Fluent Bed. But of course, we don't have 800, we have 50. And it's not the goal to have 800. I think that the goal is to solve the problems, because also maintain 100 plugins takes time. So we also care about security. So if you look carefully right now, when you do login stuff, you receive your log messages from the file system, from TCP, UDP, but likely your logs are going out of the service, right? They're going to a cloud service or a database, and I would say that 99% of the time is a network operation. And right now, you need to rely on security, and that's why we have a integrated Embed TLS in our network layer. So how Fluent Bed works internally? Basically, we have one single thread, one main process, and some people will say, hey, why you don't have multi-process? We're going to explain that later. And we have different input plugins. So the main event loop is in charge to coordinate. You can think about that. That is a kind of, we have a scheduler that runs on that special event loop that coordinate the whole work that is required by the plugins. So for example, input plugins can say, you know what, I'm listening messages over TCP, and this is my TCP socket, so please let me know when I have a new message. So who coordinate that thing, saying, hey, there's a new data coming for you, and pass the control to the input plugin is a scheduler who's running on the main event loop. Right after some plugin get their own data, transfer the data, it passes the data to the filters. Well, actually, the input plugin doesn't know about filters. They just indent the data through an API, but that API does filtering. And filtering is filter plugins that take care about to parse the data, filter the data, or append some record. Once the data is processed, it goes out through some output plugin. And of course, you can set the data to one destination or multiple destinations. So when you are doing data processing, in Fluent Bit, we care about a lot about, OK, we cannot assume that everybody is going to use JSON, because that is a lie. Everybody uses JSON, log format, raw text messages, and so on. So we come up with a way to also to consume all those log messages and provide a layer to process all that data. Because at the end, in your data analysis phase, you are not going to parse all raw text messages. Actually, you're going to try to find some key values that are interesting for you. For example, if you're parsing Apache Web Server logs or Nginx, maybe you are interested into the status code, I don't know, 500. Everything that was an internal server error. But you don't want to parse the whole row of the message, because maybe that message has, I don't know, 1,000 of lines. So it's maybe just to focus on a special fraction of that data and continue parsing of that. And for that, we provide backends based on regex, JSON, LTSB, and the new one is log format. We also can do lookup timestamp resolution based on the log files. This is all about Fluent Bit, but this is based on Fluent D. Fluent D supports this for years. So how the things works? An input plugin, when it consumes a log message or whatever, it generates what is called a record. And a record is like a small array that has two fields. One of them is a timestamp. That means when this message was generated. It's up to the plugin say what was the time, not up to the engine. And then the message, that the message can be a map. But when I talk about message array, I'm not talking about JSON. You can think about JSON, but we use something that is called message pack, which is like a binary version of JSON. So message pack is like a serialization format and a specification that has implementation in different languages for C, D, Golang, J, Python, Rust, and so on. A message pack was created by the Fluent D creator before Fluent D. A message pack is very well known, and the thing is that you have a binary format. If you are going to do some parsing or you want to iterate the fields of your data, you're not going byte by byte, because the format said, okay, you're looking for the key number 3, okay, please jump to the offset, I don't know, 100. So you keep parsing all that data. So you just jump between values. Okay, so when the input plugin generates these records, maybe we have this, not maybe, we have the notion about tagging, because you need to add some notion about or some label from where this data is coming from. Because maybe we have input plugins consuming from the file system, maybe we had an input plugin consuming from TCP, or syslog in this case. So we said, for example, input plugins generate 3 records that has a tag apache.bhost1, and 2 records that come from, we attached some syslog. So what happened next? These messages go to the storage layer. Storage, when I'm saying storage, means that, okay, these records are being saved somewhere for a temporal space, maybe in memory, maybe in the file system. Until the last version of Fluent Bed, because today we're releasing 1.0, we support just memory buffering. Okay, and that was quite good, because it's not that bad. Because if you think about a Kubernetes use case, what is your buffer of data? Your buffer of data is your log files. So if something goes wrong, it doesn't matter because the data is there. But what happens if you're consuming data that doesn't come from log files, from TCP or whatever? You need to be able to continue consuming data and store this data somewhere. But of course, your memory in your system is limited. You don't have like gigabytes free to do whatever you want. But you can do that with the file system. So once the data get into the storage, then it jumps into the routing phase, meaning where is this data going to? For routing, if you remember, we had this notion of tagging. So in the output side for plugins, when you configure this, you said, OK, I'm going to take out all the logs or messages that has a special tag. They are going out to a special output destination. And for that, we have this notion of matching rules. So right now, in the newer version, you can do matching rules with wildcard or with regular expressions if you want. So one of the challenges that we had when we were creating or designing Fluent Bed, we said, OK, this will run in a single process. We get the data in, and we're going to send the data out. But most of the places where the data is going out is network operations. if you have been done some programming with TCP, that means create a socket, resolve an address, connect to the address, wait for notification, and that process sometimes can take, well, takes times, and that can block all your program. So how do we avoid that? Have you heard about the callbacks hell? So you know about Node.js, right? So the thing about the callbacks hell is like if you have one event loop who's handling events, people create this kind of notion of, OK, if this event is happening, I'm going to call this function. If this another event is happening, an event I was able to connect to the server, I'm able to write data to the server, those kind of events. But when you write this kind of model with callbacks, it's quite hard because you are trusting that the developer of that output plugin knows what he's doing. And sometimes they don't, because they don't know what would happen with a network problem. What happens if I'm writing my data and the socket gets closed or get a notification from the kernel? We can leak data, we can leak memory, or we can get many problems. So we come up with a design where we're trying to reduce the blocking time in the process and try to defer all these tasks that we're blocking. So this is like the common thing that we was explaining last. If you're going to send data to a destination, we basically create a TCP connection, convert our message pack internal representation to the outgoing format, because Elasticsearch, for example, is not waiting for message pack. It's expecting for JSON. So I need to convert my message pack to JSON, and that happens in the output plugin context. Then I write data over the network, wait for a response. A 200 was OK, or maybe another error. And after that, the router or the engine said, OK, it was OK, I need to retry this, or there's an error. So how do we solve the problem here? If you look carefully, all these tasks about create a TCP connection, write data over the network, or wait for a response, is that something that we can ask for that and wait until it's finished? But why are we going to block our program for that? So that's why we come up with implementing coroutines. Maybe if you're using Golang, you're quite familiar with coroutines or on a way to suspend the execution of your function and just wait that somebody wake you up and restore that specific entry point where you were working. I'm going to explain that with a code now. So implementing coroutines in the output plugins was a solution because we abstract how the developer of the output plugin is handling the connections, how it's reading data, and so on. So all about the network operations, error status, and that kind of things, the Fluent Bit API take care about that. So we reduce the risk of memory leaks or any kind of problem. So how this works? This is just a fraction of the implementation of the Elasticsearch plugin. Well, this is a callback, but it's a callback for the plugin, for the registration. It's not a callback hell. So if you look carefully, for example, on line 8, what happens here is we are creating a connection to the TCP server. But if you look carefully, we just trap an error. There's no more than that. If there's no error on line 14, we are just formatting the data from message pack to the expected JSON payload by Elasticsearch. OK, this is fine. Then we are creating a an HTTP context to send this data that was just formatted. Then we issue the request, and let me check this. Oh, we cannot show the last line. So, well, anyways, after that is releasing the buffer and returning. If you look at visually at this code, you will see that this is a blocking code. But internally, every time that you issue any kind of network operation, and I'm focusing on this place, like upstream connection get a connection to an upstream server, mean create a socket, connect, and be ready to write data, Fluent Bit with the coroutine is going to suspend the execution of that function. And then we'll continue working processing data. And once the kernel notify, hey, the connection is ready, it's going to resume from that specific entry point. So with this kind of model, we avoid many problems with network I/O or leaking data or whatever. And of course, at the beginning, it's not too straightforward to implement the design internally. But after that, we come up with a solution where you can write your own plugins in a safety way. Of course, you can leak memory if you don't write good code, right? But that happens to every person. And OK, that's what we suspended while the connection was done. We resumed later. And then when we issue the HTTP request, that means I'm going to send my payload to the server. I just enqueue the data, and I suspend again. Because I will tell the kernel, please let me know when you just flush the data. I'm not going to sit and wait, right? I had things to do. And then when I'm ready, OK, I'm going to resume. And the internal API is going to validate the status and so on. So this is the most simple example of how this works internally. And it's very reliable. And at the end, a plugin can return 3 statuses. First one, OK, that means I was able to flush the data. A retry, for example, if I got a problem, for example, here, a return, I issue a retry, right? That retry means for the engine, oh, something happens, the plugin is asking to retry. But it's up to the engine and up to the configuration say, OK, you are allowed to retry again or you're not allowed. Well, if it's not allowed, you're not going to tell it, right? If I have to retry, I'm going to call that function again later with the same payload of data. And sometimes maybe you can get an error. Like, you know what, I was not able to format the data for Elasticsearch, and there's nothing I can do, so this is an error. Please don't retry, basically. So also internally in Fluent Bed, from a developer perspective, we have many helpers to do different operations. I just explained it about the network operations. But also we support, for example, OAuth 2. We support timers. We support crypto. Because if you're writing, for example, an output plugin that you rely on TLS, which is security, a secure socket layer, you don't want to do your handshake manually. You just want to put your own certificate files and let the plugin or the engine do the whole work. Because the handshake says, go, send a credential, get in bad, do the signature, blah, 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 blah. A lot of round trips. But in your plugin, you want to abstract all that complexity. And we also support Lua, a Lua engine. I'm going to explain that. So we have 50 plugins as of today. The new addition is BigQuery. It's not in the list. But thanks for the contributor who's around here. And well, we had input plugins like Tail to collect messages, KeyMessage, which is to read the kernel log messages, originally created for embedded Linux, serial interface, systemd, syslog. And you can see most relevant, I would say that for us, for this context, is Tail, systemd, Kubernetes, Lua, and Elasticsearch. All of the plugins are built into one binary. So if you love Golang because you have one binary, here we have one binary too. OK, filtering. Some months ago, so I always tell this story. We were in KubeCon Europe. You know this story about the GDPR, right? Or security, blah, 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 blah. So they said we are using Fluent Bed in production, but we need to obfuscate the data. Oh, perfect. Why you don't write a plugin? Yeah, but we need that our plugin does if, else, then, otherwise, do this thing. Can we put that in the configuration? No, because otherwise we're going to add complexity. Why you don't write a plugin? Yeah, because it will take more time to write all the plugins, all the options. OK, so we come up, everybody, with people who were that were Fluent Bed users and others. They said, OK, why we don't implement Lua scripting? So we implement a Lua filter that will call a Lua script that you can load in your own configuration, in your own config map. So you can replace values, make conditionals, or whatever you want in a very easy way like this. This is a simple function that takes the tag of the record, the timestamp, and the record, and basically just create a new entry, assign some values, and just return. This created a new record into Fluent Bed with I don't know, 4 lines of code, 5 lines of code. So it's really good. And of course, you have a performance penalty, but it's really low. But that is where you put your balance. So do you want performance, or do you want to solve your filtering needs? Tell me.
Does it also change the tag?
No. I was expecting for that question later, but yeah. We are going to support retagging in the next major version. We are planning to have it at the end of January. But we're going to talk about the roadmap in a different session after this one. OK, log processing in Kubernetes. I'm going to explain really quickly how this works. If you log processing in Kubernetes means that you have pods that are running in your nodes, and every pod can have many containers, but the logs are physically in your node, because that's how Docker operates, right? By default, we are using the file system to store the logs. So the pods or the containers, the application that runs in containers, generates some output information. That information goes to the file system, and then what you do is to deploy Fluent Bed or Fluent D as a daemon set. A daemon set is just a pod that runs on every node. And this specific pod, what it does is to consume all the log files from the node, from the containers. Of course, you have to mount that volume. And once it consumes the logs, you know that in Kubernetes, you have the notion about labels or annotations. So, but those labels and annotation are not in the node context. They are in the API server outside. So what does our filter does, which is called filter Kubernetes, which was a strict copy of the Fluent D filter Kubernetes, it just go to the API server, gather the metadata, and then just put everything together for you so you can do your own data analysis. Please show me all the logs in, I don't know, Elastic, all that is labeled blue. And you will all together. Doesn't matter if you had 10 replicas of that application, it's distributed in 20 nodes, but it will work. So a simple message like this was generated from a Docker perspective. So the application just said, hey, Seattle. But in Docker, at the file system level, you get the log messages, the stream from where this data comes from, and the timestamp, meaning when this data was generated. And after that, your ending log message is like this, where you have all the Kubernetes context, the host, the pod name, the container name, the namespace. IceCubeCon. Who went to IceCubeCon? Did you went? Yeah, it was in the waitlist. Could not find it. So yeah. So a simple message in the cloud native space, of course, get more addition, a lot of context. So any kind of log processor that you're going to use, can be Fluent D, Fluent Bed, or whatever you're using, needs to be aware about how to enrich your logs with metadata. Otherwise, you're going to lose context. So one of the features that we implemented, I think that was this year, well, what is the problem? The problem is that, OK, everybody's deploying pods, right? Application. Every application has a different format. And there was no way in the logging processor side to say, oh, this data is this format, this pod is this format. So we come up with a solution that why we don't allow to the guy who's deploying this pod to say, to suggest a parser for their own data. So we implemented this annotation inside the pod, where Fluent Bed, when it's talking to the API server, is getting in all the data and, well, all the annotations for that pod that is running. So, and also before to merge all the data, it just look for this special annotation, fluentbed.io/parser, and set Apache. And for Fluent Bed, Apache is a parser that is known in the configuration. So it knows how to parse Apache. So you don't mess up with a whole raw text messages in your database. And also, we got contributions this year from Don, who's here in the audience, who he expanded this. So one thing was to suggest a parser. But maybe your pod can have many containers. And containers stream data from standard output, standard error. And trust me that there are people who put different formats in the same container for different streams. So yeah, this was the implementation where you can mix up the options and try to accommodate how from your pod you're going to suggest a parser, or maybe you can say, please exclude the logs from this pod. Because maybe there are pods that are from testing, they are too noisy, and you don't want to have that data in your database. We implemented also, this is not new, but Prometheus monitoring. So we have built-in metrics in JSON and in Prometheus format. So you can put your own logging layer, and you can put your own Prometheus operator consuming those metrics for you. OK, so Fluent Bit 1.0, release it today. Fluent Bit 1.0, we counted the contributors from the last 0.14 version up to now, and that is more than 30 people. So thanks so much for contributing, these individuals and companies. We also, from an ecosystem perspective, the contributors are focusing on how to improve testing and CI. So when a project grows, when things start to grow in terms of extension, architectures, and for the next year, portability, we need to have a way to make sure that the things that we're doing are running right. Okay, that is all the CI thing. There are integrated sanitizers now for memory leaks. And also, just some news, since March of this year until now, we have around 18 million deployments. Well, it's 17, that's something, almost 18. And that's a lot. So every day we got like 100,000 deployments in Kubernetes. Because somebody is running a node or spinning up new VMs for their cluster, they're using Fluent Bed or Fluent D. For Fluent D, we have their own metrics too. It's a couple of million more. So here we're focusing on Fluent Bed metrics. So, and I think that after look at the metrics and the contributors, it was a really good timing to release that 1.0 because it's really being used in production. So what is coming up in this 1.0 version? One of the things that we have a new storage and buffering mechanism. So when I said at the beginning that buffering is really important, by default, we always use memory. But now we have a way to store the data in memory, but also in the file system, just in case something happens, we have a backup of that data. The metrics, in the metrics side, the filters didn't have metrics, but now they have it. We have a new parsing log format backend. We have an improved Kubernetes filter. We improved Lua filter. We have a new BigQuery plugin. But there are many changes that, of course, we're not going to list here because there are bug fixes on most of the plugins. We have performance improvements, improved documentation too. That is really important. So talking about the storage layer pretty quickly, we started to designing a way to how to sort or have a better notion of how the data is handled internally in Fluent Bed, but how to come up with a representation, an agnostic representation in the file system. So we come up that this will be a root path, right, where you're going to store different streams of data. This is the storage layer is an agnostic library, but it's being used by Fluent Bed. So the streams of data for our use case are the input plugins. So every input plugin will have its own stream of data. And then when they ingest a bulk or chunks of data, that becomes a chunk file into the file system. Okay, and each chunk has this design. Pretty quickly, we have a header, 2 bytes. Optionally, it's disabled by default, but you can enable CRC32 for checksum, just in case you care a lot about data integrity and you can come up with a high I/O, you can enable. And in the content side of that same file, we have a space for metadata. We have 2 bytes to specify the length of the metadata. And for metadata, for Fluent Bed, it's a tag. So every file chunk in the stream in the file system contains the tag plus the data. And then we have the content. So we did a lot of testing and performance tests over this design. And well, this is the final design. We did a lot of iterations. We started with a SHA-256 for checksums, but it was really expensive in terms of computing, but I think that this solved the problem. So yeah, that was the presentation. I hope you are using Fluent Bit. If you don't, you have questions, please let me know now. Oh, there it was first.
So between Fluent Bed and Fluent D, if you're starting this new, what would you recommend?
Okay, the question is, if you are, I'm getting started, what will we recommend, Fluent D or Fluent Bed? Fluent D, 800 plugins, and 800 updated in the last year. Fluent Bed, 50 plugins. So what are plugins are different kind of features or things that maybe you depend on. If you're running Kubernetes and you need special filters that, or input plugins or output plugins that doesn't exist in Fluent Bed, you should go with Fluent D. If Fluent D is too heavy, maybe you should consider Fluent Bed. But also, what some people does is put Fluent Bed as an agent in the node, as a daemon set, but then they use a Fluent D to aggregate the data. So you make Fluent Bed talk to Fluent D, because both can talk each other. But there's not like a straight rule for that, because every use case is different. So the thing is that we thought some years ago, okay, somebody's going to make something for cloud native, more lightweight, or we do it, or somebody else will do it. So we do it, and now you can choose between the two options, but it depends of your own use case. Yep. The difference to write plugins for Fluent D and Fluent Bit. For Fluent D, you just write plugins in Ruby. So it's all about Ruby gems, so I think that is quite straightforward. But for Fluent Bit, there's a complexity, because as of today, the plugins are in C language, 1, and 2 is static linked. Right now, we are going to implement shared plugins, so shared library for plugins, so you can write your own plugins outside of the binary and just link it on runtime. But in Fluent Bit, I didn't mention, but we support plugins in Golang. So you can write your plugins in Golang, but there's not an issue, but it's a performance penalty. In the integration in the Golang world, when you have your C code running and you're going to call this Golang code, so the Golang code includes all the things that Golang needs to run. So it does a context switch, which is really expensive in terms of computing, but all the engine of Fluent Bit is shut down until the Golang function returns. So for the Pivotal, these guys are using the syslog. They create a syslog plugin in Golang. It's working for them. But I think that if you have really intensive load where you're shipping thousands of logs per second, maybe you can face some performance penalties. But I think that it depends on the use case and the load that you have in your system.
We are using Fluent Bit. We used Fluent D before, but we had performance issues with it, so we switched to Fluent Bit. And we use what you referred to earlier, was a collector and aggregator model.
Okay.
Both are in Fluent Bit. So I ran into two things that seem to be missing in Fluent Bit as opposed to Fluent D. One is these two, when you use the forwarder input and output, can't be done TLS-based.
Yeah, the in forward in Fluent Bit doesn't support TLS, just the output.
And is that maybe on the roadmap?
Yeah, it's in the roadmap, but honestly, we didn't have any priority before because we didn't have the storage layer in the file system. Because I think that that was more relevant. Otherwise, you're consuming data, your memory will go up, and everybody will complain about it, right? But now that we have the file system buffering, we don't have excuse to do not implement it. So that is something that we have to do this year. Yeah.
And sorry, can I ask another quick question?
Sure.
What we managed to implement in Fluent D was based on the Ruby regex is dynamically determined which topic Fluent Bit's Kafka output supports the multiple Kafka topics, but it's statically defined in the configuration which it can use.
Yeah.
Being determined on, let's say, runtime, which you need to go to.
Yeah, the question is the output Kafka plugin that we have, it doesn't support dynamic topics. Okay, that was a limitation that we have in the backend library that we use, libRtKafka, where you have to predefine your topics. I think that that is solved in some way, but I need to do some research because I know that we're getting a lot of feedback. Okay, everybody's asking for a flexible way to define topics or indexes for Elasticsearch. Is that something that we need to solve? But for the Kafka specific case, I think that we rely in the features of libRtKafka, which is like the C library version that provide the protocol stuff. So yeah, let me do some research on that because I don't know if it right now is supported, but 1 year ago it wasn't supported. Oh, you have a question first, sorry.
Yeah, so we have the same requirement requiring TLS for the core protocol.
Okay.
We ended up using Ghost Tunnel to do TLS parts. So that's how it worked around.
Yeah, actually, it's not a big thing from a developer perspective. So we had to implement that part of the protocol. It's a little handshake, so please. Yeah.
Security protection against noisy neighbors. Like, if you're in a multi-tenant cluster, everybody tends to, our upstream is rate limited. Do you have a way that, say, a podlog can only log so much, and then we start dropping logs because we don't want it to affect if someone is creating a massive amount of logs?
Yeah. Yeah, there's a throttle plugin filter, so you can limit the window. You can set a window of the amount of data that's flowing through. But I think that there's no way to do it through a namespace level. And I'm sure that everybody needs that. Yeah, because most of the multi-tenant environments that with people I haven't talked to that they implement multi-tenant, they say, no, we split the things with namespace. So we need to provide a context of namespace or how to get that information to apply all the rules. Oh, before we continue with the latest question, we're going to have an informal short meeting outside for everybody who wants to contribute or has some production usage of Fluent Bed, because we are going to try to handle the priorities in a better way because you're running in production, so we want to know from your perspective, what do you need, basically. If you are a developer who want to contribute or you're a company using it, please, let's meet outside. So 2 more questions, the lady. Is the input plugins in Golang? Do you develop in Golang? Yeah. No, it's not in the roadmap to have Golang input plugins, but if you want to write the interface, you're welcome. Yeah, another option is like, you know what can be done? It's like, for example, for the output plugins, we built a Golang output package, so for Fluent Bed. So in the input side, what makes sense maybe to write a simple package that connects over a Unix socket to Fluent Bed. So anybody can write their own thing to collect data and use the Unix socket interface through your own framework to ingest the data. I think that it's straightforward. It's not too hard. If you want to contribute with that, we can give you the right mentoring to get there. Yep. Anybody else? Last one. The best way to get help. That is an ongoing conversation that we have. Actually, we have channels, but we need more people to help. That's the thing. But we have Slack. We have a Slack channel. We have the mailing list. Sometimes it's something that we need to improve for the next year to be more, proactive in communication. But we have the channels: Twitter, mailing list, and Slack. Well, you can send us an email anytime to bother us. Oh, cool. Unless you are from China. Yeah, that's the problem that we got from KubeCon China, right? Hey, join Slack, we can't. Hey, join the Google group, we can't. So we're trying to find another way to these guys jump in, because Fluent Bit is also being used a lot in China.
Set up a Fluent Unit stream somewhere.
That's a good idea. Yeah. A free VPN for these guys. Okay, one more question. Somebody, you had one.
So we use one thing is multi-tenancy, so we have one thing set when we dynamically generate configuration, and then once configuration change, we bounce the new set. So now we plan to move to a new thing. Can we still bounce the Fluent Bit because we use a file buffer in the Fluent Bit, and you say you're not supporting file buffer?
Yeah, we are supporting file buffer right now. Yeah, that's the new thing. Yeah, of course, it's just implemented. I think that nobody's running in production, but you can be the first. Or in testing. So I always say that because sometimes people announce new features in the products, and sometimes things are not quite stable. So I think we did our test. We did the storage layer as a separate project, so we make sure that was working, has a good performance. But when you run in production, the things is different. So we need feedback on that. It's just implemented, but maybe we need some iteration of tweaking, performance improvements, or I don't know. OK, I think that we are on lunchtime now, right? So maybe if you want to have this quiet meeting, we can have it here, because there's nobody using this. OK, thank you.